All right, so in this lesson, we are going to identify and interpret the slope and y-intercept again of a linear relation, but this time we're going to be given the graph, or a graph of the linear situation. So Desiree starts a Mr. Lopez fan club. She rents a car to drive all over America and tell people about it. So the y-intercept, remember the y-intercept is always where the independent value is 0, in this case, where the distance is 0. So it's going to be right where it starts, right here, because this is 0, 11. Now in terms of the story, what does that mean? Okay, so that's the cost and that's the distance. So the distance is 0 miles. The cost is $11. So this means it costs $11 just to rent the car. All right. And the slope. So let's talk about the change in cost over the change in distance. I actually, if you notice, I like using the units for the independent variable. So I like to put cost over miles. So change in cost over the change in miles. Change in cost over the change in miles. You can do it any way you want. As long as, like I don't know. Like you could put change in distance if you want here. I just prefer to put the unit because the equations make a little bit more like sense to me like faster, more quickly. So change in cost over the change in miles. Okay, so let's find some nice integer value points. Here and here. So I'm going up. The cost increases by $2. So, okay, so let's do this. That's up 2 and right 3, but I'll put it there. Okay. So the cost increased by $2. So we went up to right 3. That's what I was trying to say. So I'm actually going to do this instead. Up to right 3. And you can tell that the same pattern can be repeated over and over again, constantly the same. Even if you started like right here, if you could find a way of counting exactly 2, if you go to, and then exactly 3 to the right, you would end up back on the line. So up to right 3. So up to right 3. So if you move up, it's positive 2. If you move right, it's a positive 3. Positive over positive is a positive. You can't reduce. And that's 0.66 repeating. So the cost, let's interpret the slope. The cost increases by $2. Let's write that a little bit nicer. It looks like a Z. By $2 when the distance, or you can say number of miles, when the distance increases by 3 miles. Yeah. Cool. Not too bad, right? My equations. So my dependent variable, the one I care about, is the cost. Remember that, well, this time I'm going to write 4, so leave some space. The costs start off at, I think, yeah, $11. And it increased by 2/3 of a dollar every mile. Cool. Or we could say the costs started at $11 and it increased 0.66 cents per mile. Those are our first two. And then, but normally we don't write it like this. We actually will write the fraction first. So that's a positive 2/3. So positive 2/3 m. Don't forget the m. And the 11 is a positive. So, and let me interpret this. The cost is $2 every 3 miles, or 2/3 of a dollar every mile. So the cost is 2/3 of, oh, I can't even do that. The cost is 2/3 of a dollar every mile plus the initial fee of $11. Or you can say the cost was 66 cents per mile plus the original $11. Okay. Next problem. Jesse's playing a video game and loses lives over time. So the y-intercept, remember that's when the independent value is 0, so the time is 0. So 20, 21, 22, 23, 24, 25. That is my y-intercept. 0, 25. So remember, he's playing a video game, he's losing lives. So Jesse starts off with, oops, I'm gonna write off over again. So Jesse starts off with 25 lives. Okay, that's cool. So let's figure out what happens. Let's find some nice, okay, there's one right there, right there, right there, right there. And it keeps going. Well, sort of. You can't have negative lives. But lives go down by 1 every 2 minutes. Down 1 every 2 minutes. I remember, like I said, you could technically start right here and go down 1 every 2 minutes, but it's sort of hard to count that way. So we don't really, just like, we don't do that. We could, but it'd be difficult. So we have a change in lives and a change in minutes. Change in lives, change in minutes. So the lives, so we go, oh, let's just do it like this. So we go down 1, right 2. This means that we have a -1 over a +2. Negative over positive is a -1 over 2. We can't reduce it, so we just leave it. -0.5. Cool. So the number of lives decreases by 1 life when the, I don't know what time, increases, right? Yeah, increases by 2 minutes. Oops. Minutes. Okay. Write some equations. So we're talking about the number of lives. He starts off with 25 lives. So the number of lives is 25, and he loses about half a life every minute. Or we can say his number of lives are 25, and it decreases by 50 hundredths of a life every minute, which is 1/2 of a life every minute. Let's go ahead and write the other ones. This is where you gotta be careful. I'm gonna do this. That negative is with the 1/2 m. That negative is with the 0.5 m. So when you write this first, you have to put -1/2m. And then that 25 is a positive 25. So it's plus 25. So here, instead of writing 0.5m, we're going to write negative 0.5m. That 25 is a positive, so we'll put plus 25. I'm going to go ahead and outline that right there. So that, and this, that, and this. And that 25 is a positive. Cool. And that is it. Thank you.